In this video, we are going to look at weather forecasting. We're going to look at a couple of techniques of forecasting and the different types of forecasts. Now, forecasters, of course, are very famous for not always getting things right. We make a forecast, we say it's going to rain today, and not a drop of rain for the day. Why is it that forecasts can often go so wrong? When you're in a regular science class, they give you a situation and they say, what's the outcome? And you can get an exact number. You put it in a lab, you get that exact result. However, every time this happens, it is a very set experiment or a set circumstance where you can eliminate a lot of the outside variables. However, with weather, you can't do that. You can't say, well, let's get rid of the let's get rid of the humidity, or let's ignore the wind for this case, or friction, or whatever. We can't do that. We have to take absolutely everything into account, which is impossible. You cannot do it. It is way too hard. Even computer models, if you calculate absolutely every single little thing, then by the time that the computer has finished making a forecast, it'd be a week late. So we can't ignore all the variables, and yet we can't include them either. So what we have to do is we have to make a few assumptions. We have to simplify the computer models. Not eliminate variables, but simplify it, make it easier for the computer to work with. Another problem that forecasts can have is that there are some models that are not global. Now, can you imagine having a model that does just the United States itself, but has no idea that there's a hurricane just outside of its range? That could greatly affect the forecast. Excuse me. In addition, there are certain regions where there are very, very few observations. Good example of this would be desert regions, or the poles, for another example. Middle of the ocean. There are so few stations in these areas that we can't get enough observations to make a viable forecast. We also can't model small-scale features. For example, a small mountain. If there's one small mountain in a region, then the model assumes that's pretty much flat land. Because if you have every single detail, every single mountain in the way, then it gets way too complicated for the computer to handle. So the computer forecasts one thing, but because that mountain is really there, it's going to cause the wind to change a little bit, could create a bit of a storm. It can create a lot of differences. We just can't factor everything into a model. So how can we get reliable forecasts assuming seeing all of these challenges that forecasters have? We use what we call ensemble forecasts. Another nickname for ensemble forecasts is the spaghetti model. I'll show you that in the next slide. It is a very robust method, a very good idea, and a very good method to creating a strong forecast. Here's the idea behind the ensemble forecasting. What you do is you take a computer model and you run it. And then you take that same computer model and you tweak it a little bit. For instance, you say, well, let's increase the wind speed a little bit. Let's increase the humidity a little bit. Just slightly vary the conditions. And you run it again. And then you vary conditions and run it again and again and again. And you get a couple handfuls of these model runs. And then you take an average of all of those results. Here in this figure on the right, you can see a handful of model runs. That would be these individual thin blue lines, or here the individual thin red lines. Those are the results of different models. Now, sometimes these lines are going to be close together. For example, here, notice that all of the lines are very close together. That shows that there's really good reliability between all of the model runs. So you take an average of all of those model runs, and that's a good result. But there are other times where the lines don't line up quite as nicely. There's a lot more variation. In that case, there's less reliability, but taking the average here, which is the yellow line, taking the average is still more reliable than any one model run by itself. And so using this ensemble forecasting has proven to be a huge benefit and improvement to weather forecasting. Okay, so you've run your model, you've got yourself some plots, some maps. How can you take that information and generate a forecast? We're going to talk about a few different techniques in creating a forecast. The first technique is called persistence forecasting. Basically, whatever the weather is now, that'll be the same weather later. A good example of this will be when you have, say, 5 or 6 very sunny days without rain here in Florida. You have 5 or 6 days sun, no rain. What are the chances that things are going to change tomorrow? Not likely. So we're going to do a persistence forecast and say, since we've had 5 days of sun without rain, tomorrow's going to be more of the same. There hasn't been much of a change. So we're not predicting any change. That's persistence forecasting. Another technique is trend forecasting. When you see a pattern happening in the weather, you follow that pattern or that trend, and that will lead to the weather tomorrow. So, for example, 5 days ago was rather cold. 4 days ago was cool but a little bit warmer. 3 days ago was warmer still. 2 days ago was warmer still. Yesterday was still a little bit warmer. Today is the warmest of all. So the weather has been the temperature has been gradually increasing day to day. So tomorrow we're going to forecast a temperature that's higher than today. Trend forecasting. Another method or technique for forecasting is the analog method. Basically, you say this weather event is similar to another event so many years ago. For example, if we had a tropical storm or hurricane form in the northern Caribbean that is slowly moving northward, then I would immediately say, oh, this hurricane is very similar to Hurricane Sandy back in 2012. And so you look at what happened with Hurricane Sandy, look at the conditions that happen right now, compare the two, and look at the similarities. That's the analog method, looking at the similarities between current and past events. The statistical method looks at what we call model output statistics. Basically, the computer itself looks at the model and generates numbers. Here we've got a link. Let me just navigate to that quickly, just so you can see what it looks like. Here is an example of model output statistics, or MOS. This is made by the GFS Global Forecasting System, Model Output Statistics Forecasts. We're looking at Daytona Beach Airport for the dates of June 10th, June 11th, and June 12th. And this slash here indicates 0 Universal Time Coordinated, or 0 UTC. And then it just plots out all the numbers. For example, the high for June 10th is 89. And then UTC, we're looking at sunset right about this time, a little bit after. Local time is still June 10th, it's June 11th UTC, right up until about here. And then you reach a minimum temperature of 73. Then tomorrow's high will be 92. The low that night will be 75. The next day, June 12th, we'll have a high of 91. And look at temperatures through the day, dew points, cloud cover, wind direction, wind speed, so on. So basically just actual numbers. That is another method of forecasting, is using the statistical or model output statistics method. Climatology or probability is another forecasting technique. You make a forecast based on the climate of a region. A good example of this would be a forecast saying, on August 6th, I predict that there will be a sea breeze, which generates thunderstorms in the afternoon, creates lots of thunderstorms, lightning possible, dying down towards later afternoon. That's a climatology forecast. Why? Because it's what always happens here in Florida. It always happens that way. The last type of technique we're going to look at is weather type. We look at the weather associated with whatever system is coming through. Or, for example, looking at the weather associated with a front. We've got a cold front coming in. What can we expect with a cold front? We saw fronts in Chapter 8. You can go back to Chapter 8, look at those charts. What you would see is the temperature with a cold front would be gradually decreasing. Dew point would increase and then drop significantly. Pressure would drop and then rise afterwards. Wind direction would change, so on. What is the typical weather that you see associated with a weather system? Those are very common forecasting techniques. Now once you have your techniques, now we have to actually make the forecast. We have different types of forecasts that we work with. We have what's called the nowcast, looking at hours worth of forecast. The short range forecast, which is looking up to a couple of days. The medium range, which is a few days up to a little over a week. And a long range forecast, which is pretty much anything beyond a week. Those are the four basic types of forecast. And we generate these different types of forecasts using the techniques we saw on the previous slide. Now, what makes a forecaster good? What shows that he has skill? Well, we look at the accuracy of a forecaster, and generally up to 24 hours, our forecasts are pretty accurate. Once you start going a little bit further, 2 to 5 days, we can still get really good forecasts, but go past 5 days, go past a week, you can see things changing so quickly. I remember having a forecast once where I saw a hurricane developing very strongly, could have been a Category 3 or Category 4 within a week. But the very next day, the hurricane was nowhere to be seen. The one slight variable changed, and that completely eliminated the development of a hurricane. So, bottom line for accuracy, the shorter the time period, the more accurate you are. The longer time period, the more you can have that goes wrong. And the more you're going to need to change your forecast as that time actually approaches. Now, the skill of a forecaster is measured that you are more accurate than utilizing persistence of climatology. So, if I were to say August 6th, we're going to have thunderstorms in the afternoon, woohoo, that doesn't show I'm very good because that's what always happens in Florida. But if I were to come out and say August 6th, we're actually going to have very clear skies, not a cloud in the sky, not a single bit of thunderstorm, and no wind at all. And that if that's what happens, that shows better skill, because that is not usually what happens with here in Florida in the middle of the summer. Now those are some of the techniques and the different types of forecasting. In the final video for this chapter and in the final sections of the textbook, we're going to look at actually performing a forecast.